So, how's everybody doing out there? Well, welcome to day 19 of Corona Online School. And today we're going to talk about volume. So, we're actually moving into more three-dimensional objects like we had done before. So, in this case, let's first talk about what is the definition of volume. So, volume is the amount of objects or water, whatever it happens to be, that can fill up a three-dimensional object. So if you were thinking about like a fish tank or something like that, it would be the amount of water that would actually go into that fish tank. So the amount of objects can fill up a three-dimensional object. And so if you remember, like units for volume are always going to be something cubed. So like, inches cubed, centimeters cubed, feet cubed, where area was always, like inches squared, centimeters squared, that kind of stuff. So volume is always cubed. And so what we want to be careful of, so we're going to start off with our investigation with the volume of a prism, and we're actually going to use that to kind of help us build all these other different kinds of shapes, which is kind of cool. So now be careful when you think of prism, like, if you remember when we studied this a while ago, prisms are a lot of different types of shapes. A prism is based off of its base. So you can have a square prism, you can have a rectangular prism, you can have a triangular prism, you can have a hexagonal prism, a pentagonal. So it's all determined by the base itself. So when I say, what's the volume of the prism, the first thing you might think of is length times width times height, which is true if it's a rectangular prism or even like a square prism. You could pretty much use the same thing. But kind of keep in mind, we can study any kind of prism, so don't think that that's the total volume. So with that in mind, what I wanted to do is kind of work through example one just to give us an idea of how we want to come up with these formulas. And the goal is we want to be as generic as possible so that it applies to any kind of prism, whether it's a pentagonal prism, square prism, whatever. So we want to make this formula as generic as we possibly can. All right, so in this case, we've got two different kind of prisms. We've got a right triangular prism on the left, and then a square prism on the right. And so just like you were thinking with the length times the width, like you can probably come up with what these areas or volumes would actually be. So in this case, if we look at the triangle first, so the way to think about when you're talking about volume, what you're doing is you're kind of finding the area of the base first. So in this case, it would be 1/2 width times width, or 1/2 width squared. And then the idea is, like when you're doing volume, you're just basically repeating that triangle a bunch of times so that you can fill out that length that we're actually looking for. So what you're doing is you're taking this one triangle and kind of like putting another triangle beside it, and another triangle beside it, and another triangle beside it. And it ends up being that you're basically adding up a bunch of triangles, and how many you're adding would actually be h in this case. So our volume of a right triangular prism is 1/2 w squared times the height in this case. And so same thing's true with the square. Square and or rectangle aren't that much different. So again, we've got the area of this square, which is side squared. And then again, if you took that square and just kind of grouped a bunch of them together, added all of them up for a length of h, we'd end up getting that our area of our square prism was side squared times h. And so again, if we look at these things, they're two different formulas because they're two different types of shapes. And we could create formulas for all these different shapes. But the goal is we want to write this as generically as possible so that it applies to any shape out there. So hopefully the one thing you notice, one of the two things that we notice in common is, of course, they're both multiplied by the height, or the height in this case of our three-dimensional solid. But the other part is just the area of the base for each of these guys. This is the area of the base of a triangle. And this is the area of the base of our square. So in this case, what we can say kind of more generically is that the volume of these two prisms together is the area of the base times the height in this case. And so what we'll do a lot of times is we'll shorten the area of the base to just be capital B. So what we're going to do is let capital B equal the area of the base. So down below, we can actually put the volume for the formula of a prism in general is going to be B times H, where again, B is the area of the base. So this way, it's as generic as possible. If our base is a pentagon, we just have to find out the area of the pentagon, multiply it by the height. If our base is a square, we find the area of the square, multiplied by the height. If our area is a triangle, find the area of the triangle, multiplied by the height. So again, we don't have to write down 42 million formulas for every single shape that's out there. So kind of keep that in mind as you're doing these investigations. So unfortunately, the first couple practice problems are based on being able to do stuff in the classroom. So we won't be able to do any of those, but I've tried to recreate something similar on GeoGebra. So what I want you to do is kind of skip practice 1, 2, and 3. And then what we're going to do is we're going to use GeoGebra to kind of do the same thing that we would have done in class. So the nice thing is we're going to actually go into the three-dimensional GeoGebra app in this case. So we haven't used that before, or at least I don't think so. Yeah, I don't think we've used that yet. And so what we're going to do is we're going to kind of compare a triangular prism to a triangular pyramid. We're going to compare a cylinder to a cone, and we're going to compare a cylinder to a sphere. And from there, hopefully come up with the volume formulas with GeoGebra's help. And then we've got some practice ones with the formulas. So before we get started, what I want to do is show you a little bit of how to use 3D GeoGebra since it's a little bit different. So I'm using the app. So for me, it's the 3D calculator version. So if you don't have if you're using it on your computer, I think there's either dots on the left hand side or lines, and if you click on it you want to change the 3D calculator. So just kind of click around. If you can't find it, just let me know, and then once you get into 3D calculator mode, hopefully it'll look kind of like this. So for me, I don't really like having the axes on for what we're going to do, and technically I don't really like having the plane, but I would encourage you to turn the grid lines on just so it helps you make your first, because the first drawing we're going to make is a 2D drawing, and then we're going to turn it into a 3D drawing. So it kind of helps to have the grid paper down. So to do that, if we go to settings, so I'm going to turn the axes off, I'm going to turn the plane off, but then I'm going to turn the grid on in this case. And so now that I've got that, I can just click anywhere on the screen. And so I'm going to rotate it a little bit so it actually looks two-dimensional for me. So that just makes life a little bit easier for me. Whoops, and then it's spinning on me. And so now let's look at what we were supposed to do. So let's look at some of the commands we're going to use today. So the first thing we're going to do is we're just going to draw a regular old isosceles triangle with a base of 6 and a height of 3 using the polygon tool. So again, this is just like we would have done in the two-dimensional space. But then for step 2, we're going to use this command extrude to pyramid, which is going to turn this triangle into a pyramid. And then we're going to use the command extrude to prism, and that's going to turn it into a triangular prism in this case. And so if you're lucky, your picture should look something like that. So let me show you just to kind of get you on the right start here. Make sure we're on the right track. So it's the 3D calculator. So what we want to do is we want to click this button so that way all the tools open up to us. And then again, if you hit more, there's a lot of different mores there. So notice there is a pyramid button, but I'm not using that because it's kind of complicated to get it the size that you want it to actually be. And since I'm trying to compare a prism to a pyramid, I want to make sure that the sizes are exactly the way I want them to be. So that's why I'm opting to use, if you go down here to the solids, we've got pyramid, we've got prism. So these would make them for you, but I prefer to use the extrude to pyramid and the extrude to prism just because it tends to make the graphs the way I want them. I have more control over the size of them and things like that. So let me start off by drawing my triangle first. So let's go to polygon. And so I want this thing to have a base of 6. So let's see, 1, 2, 3, 4, 5, 6. And then a height of 3. So that means I want it in the middle. So 1, 2, 3. And then back to A. So there's my nice little polygon. And so now if I click on extrude to pyramid and then just click in the center of this, it's going to ask me what height I wanted. And so I think we wanted a height of 6 in this case. And so now if I grab go up to the move tool, so if I go back up and hit the move tool, which looks like a little arrow, so now I can actually kind of grab this picture and rotate it. I can look at it upside, so I've got it kind of upside down, which is fine. Like I've got it going the wrong way, but that's okay. So there's my little triangle, isosceles triangular pyramid. I don't know what I've done now. I got it going totally the wrong way. Oh, geez, now I can't get it back the way I want it. Well, let me go back and see if that. Let me go back a bunch of times. So that's a good thing. If you don't like what you've done, just hit back until you can get back to where you want it to be. There we go. So that's what I want. And so if I go to move, so let me go and make it flat again like we had it before. And so now I want to go down and hit the extrude to prism. Oh, I missed it. Yeah. And so again, just click on the thing, say we want a height of 6, hit OK. Now if everything goes well, let me go back up to move so I can see it. And that didn't go well because unfortunately my prism's on top and my triangle's on the bottom. So that means I messed it up. So let me hit undo a couple times. So oops, I didn't undo enough. Let's undo again. Oh, I still haven't undone enough. There we go. So now let's try it this way. So let's hit the move, rotate it down. And so now let's try to do it through the inside. This could be ugly. This might not work either. But now try to click the middle. Oops, that won't work. None of those are working. Let's see. Ooh, I've done this before, trust me. I'm trying to think what's the best way to try to touch it. Let me try it this way. For some reason it's not liking it. Oh, well now that's not good. Let's try this again. See, that just make it look easy for you guys, don't I? I could have swore I just click there, highlight it. Oh, maybe this is what I have to do. Let me try this. Let me hit -6 just for my altitude. There we go. I knew I had a little trick that would work. So since it's underneath, instead of doing a 6, I can do -6, and that allows me to kind of drop it underneath in this case. So anyway, so from here, like we're going to be able to use like volume commands just like we did area and stuff like that. And then the goal is, I'm hoping you can kind of see there's a relationship between the triangular prism and the triangular pyramid, and from there make a generic formula based on that. And then do the same thing with the other 3 practice problems as well, or the other 2 practice problems as well. So again, just kind of follow the steps on these guys, see if you can come up with the formula. So the collaboration for today is going to be to take a selfie with one of your drawings. So either the cylinder to the sphere, the cone and the cylinder, or the triangle or triangular prism and the triangular pyramid. So just to see that we were actually successfully able to do it and stuff like that. So I'll be around all day. So again, there's not a lot going on in this section. A lot of cool playing around with stuff. Hopefully coming up with formulas and things like that. If you do get stuck on anything, I'll be around. So feel free to shoot me a message and let me know. Otherwise, good luck playing around with this stuff, and I will see you tomorrow in class.